what's this whole iMovie project about? Here, we will introduce you to the 3 Newton's law illustrating the big idea of each 3. Don't worry even if you don't know any single thing about the Newton's 3 laws, because by the time you finish watching this clip, I'm pretty sure you'll understand the big idea. So, let's get started!
Everybody get up.
Newton's first law of motion states that an object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. Inertia is the tendency of an object to resist changes in its velocity. You may not realize this, but this law is applied to a lot of things in your daily life. Consider your experiences playing soccer. You have to kick the ball in order to make it move. So passing the ball provides an unbalanced force because every object has the tendency to resist changes. Take a look at this video. Rio and Dylan are passing the ball to each other. In this scene, the object, which is the soccer ball, is at rest. Now, the unbalanced force is causing the soccer ball to move, and the unbalanced force in this case is Rio kicking the ball. Here, the ball in motion was stopped by Dylan's foot. Now, Dylan passes the ball to Rio, which is forcing the ball at rest to move. After Dylan passes the ball to Rio and sets it in motion, Rio, who is stopping the ball, is now the unbalanced force. Then, Rio kicks it against the wall, which again is setting a ball at rest in motion. This time, the wall is the unbalanced force because it is stopping the ball in motion. The soccer ball simulation was one of the examples that applies to Newton's first law, but there are tons of other examples as well. By now, I'm pretty sure you understood the main idea of Newton's first law. Next, let's go ahead and take a look at the second law.
The second Newton's law. The second Newton's law states that the greater the mass, the greater the amount of force needed to push the object. The formula for this Newton's law is force equals mass times acceleration. If you were to push an object that's really heavy, and you were to push a lighter object with the same force, the object that's really heavy will travel less because it has a greater weight.
I'm a fireball.
Here it is, the two boys again, doing strange things, and this time I guess they're throwing backpacks at each other. I don't know why. But as I look carefully, there's actually a secret behind this. Hold on, I think I know. You can see that my bag is traveling slower than it should be. But now let's take a look at the next example.
Start!
Now here's them throwing soccer balls at each other. You see, there is another secret behind this. You can clearly see that the ball is traveling much faster than the backpack did before. But believe it or not, this ball was thrown with the same force as it was used to throw the backpack. And that was the brief explanation about the Newton's second law. Remember, if you're light, you'll move faster, and if you're heavy, you're going to move slower. If pushed with the same force.
Everyone has heard about action and reaction, but do you know where that really comes from? It comes from Newton's third law, which states that every action has an equal and opposite reaction. Everyone knows that the classic third Newton law example is a rocket blasting off. But did you know that the third Newton's law could be implicated in something as simple as leaning against this wall? This man, shown here, is leaning against the wall. If Newton's third law hadn't existed, he would go through the wall or the wall would topple over. Take a look at this video. We are all stationary until Rena pushes me, creating an action. After she pushes me, I move away, which is the reaction. As I move away, I bump into Dylan, causing another action. When I bump into Dylan, he moves away, causing another reaction. What I just showed you was an example of a human Newton's cradle. Just like in a real Newton's cradle, the force of Rena bumping into me is the force that moves Dylan away from us. In a real Newton's cradle, it is the force of the first ball that causes an equal and opposite reaction in the ball at the other end. I hope you understand what Newton's third law is now. Remember, action, reaction.